Hello students, welcome to the chemistry class. Okay, so today we are going to start with the unit 1. Okay, some basic concepts of chemistry, and as I have already told you in the last videos that we will be studying the chapter number 1. So today we are going to study chapter number 1. Chapter number 1 from exam point of view, it is important because you will get a one question from here. It is for 3 to 4 marks. It comes in the board examinations. Okay, and from concept point of view also it is very important because these chapters will give you the idea about the units, the dimensions and all those things which will be needed in the other chapters. So that's why I'll suggest all of you that you should listen the explanations properly, and whatever notes I am giving it, you should take it down by pausing the videos. Okay. So let's start. So some basic concepts of chemistry. This is unit 1 of class 11. Okay, so first of all let us try to understand what is chemistry and why we need to study chemistry. What is the future scopes of chemistry, what is the applications of chemistry, all those things we are going to study first. Okay, so first let us study what is chemistry. So chemistry is a branch of science, okay, which deals with the study of composition of properties, which deals with the study of compositions, properties and structures of matters. Okay, so chemistry is also one part of science, one branches of science where we are going to study about the composition of the substances. Like this marker is there, so what chemicals, what substances we have used it to make this marker, that is called as compositions. Okay, so what chemicals we are using it for manufacturing these markers, what are the raw materials we are using it. So those things we will be able to study only with the help of chemistry. Composition, properties. Now what is the properties of this? Like when we write it on the whiteboard, what kind of color does it gives, plus whether it is erasable or not, all this comes under the properties. So chemistry will tells us about the properties of a substances, or and another thing, structure of a matters. So what kind of structure a matter has, all those informations we will be able to get it through chemistry. So chemistry we basically study to have informations on compositions, properties and structures of matters. Okay, now in chemistry we are also going to learn about changes which matters undergoes under different conditions. Like this marker is there. So right now temperature, it is room temperature, so marker it is in solid form. If I increase the temperature to maybe 90 or 100 degrees Celsius, this marker may not be anymore in the solid form. It may burn and it may melt, or okay, got it. So that time it will be existing in the nature in different forms, right? So that's what chemistry tells us, the changes which matter undergoes under different conditions. So matters under different conditions, it has different properties, it will be undergoing different changes. All these changes we will be studying in what? In chemistry. Got it? Okay. Plus we will be studying about the laws which governs these changes. In the chemistry we have certain laws which will be governing these changes. On the basis of those laws, those changes takes place in chemistry. So in this subject we are going to study about those laws, okay, properties, structure of matters, compositions and the changes that matter undergoes under different conditions. All these things together we are going to study in the subject called chemistry. Okay. Now what are the applications of chemistry, where in which field we use chemistry? Let us try to understand some few. There are wide range of uses of chemistry are there, but some main one I have shorted out. Let us see what are the main applications of chemistry. Okay, the first one is it helps in meeting our human needs like food, medicines and other necessity of life. So basically whatever food we are getting it, how we how do we preserve food? With the help of chemistry only, with the help of chemicals, right? Then whatever food, the crops we are growing it, we are getting good productions because of the help of what? Chemistry. So that there also we are using, for producing good crops also we are using chemicals. So that is also what? A gift of chemistry. For preserving our food, the cooked food also, we are using what? Chemicals to preserve it so that it will not be spoiled, right? So there also we are using chemicals. Now, to being healthy, okay, and to live long, there also we are using what? Chemicals. What is that? Medicines, in the form of medicines and drugs. Those things are what? If those things are not there in today's world, then I think our livelihood may not be 80 years, 90 years. It may be, who knows, 10 years, 5 years also. And so many, day by day, the number of diseases are coming one by one. So those diseases, in order to encounter, who is helping us? Chemistry is helping us. Got it or not? It's the gift of chemistry only, because of which we are able to encounter all those diseases. Okay? So, and again, some more, many more things are there where we are taking the help of chemistry, where chemistry is applied. Okay? So now next, let us move on to second point, that is, it provides us chemical, fertilizer, pesticides. Okay, so this it is because of the chemistry that we are able to I told you, get a good productions from in the agriculture field, because of the chemistry, because chemistry has given us fertilizer, pesticide, insecticides. All these protect our crops from the different kinds of insects and soil related issues. Okay, let's move to the third point. Third point is what? It has given us a new materials, that is, when the chemistry has given us new material, that is what it is called, optical fiber and polymers. Okay, so all those polymers and all, so we are getting it, that is all gift of what? Chemistry. Optical fibers, it is basically used in electronic devices. Okay, so those are what? Those are all gift of chemistry. If chemistry will not be there, those things, those new materials which we have got may not be there. Okay, the last point I will be discussing on the application of chemistry is it has wide applications in war. Okay, in today's world, most of the nations, those who have those who are nuclear powers, they are boasting over the world. Why? Because nuclear weapons is very, very dangerous, right or not? So from where does this nuclear weapons has come, or from where does atom bomb has come? It is all because of the help of chemistry, because of the, it is also you can say that boom, or it's a curse of chemistry only. Got it? So these are some main applications of chemistry. And what is chemistry we have discussed here. Now you can pause the video and you can take it down, then we shall move on to the next topic. Okay, so dear students, the next topic we are going to discuss now is first of all these things we have discussed in you have already learned in class 9, but let us just once revise it. Okay, so the next topic we are learning is matter. What is matter? So we know very well, anything that has mass and occupies space, we can call it as a matter. So this marker, it is a matter because it has got some mass, and wherever I will place, it will occupy some space, right? So this one will be considered as what? Matter. Our body, we ourselves, is a matter because we have a mass, and wherever we stand or sleep, it occupies some space, right or not? So that means we are considered as matter. Anything, it can be anything which has a mass and occupies space, they are called as matter. Okay, fine, clear? But anything does not mean our feelings or our thinking is a matter. No, our feeling does not have mass, does not occupy space. Okay or not? Our thinkings does not have mass, does not occupy space, so it is not a matter. Okay, remember, anything that has mass and occupies space, they are only called as matter. Okay, fine. So this was class 9 matters. Okay, now we are going to see the classification of matter. Roughly I'm going to show you with the help of a table. Okay, so matter we can mainly classify it into two types. Okay, one is what? physical classification of matter, another one is chemical classification of matter. Matter we can divide into two, physical and chemical. Okay, so in physical classifications, basically we will be seeing that in which states does matters occurs, in which okay, physically how they are present, in which form they are present, okay or not. Those things we will be seeing in physical classifications. Chemical classifications we will be seeing what are the different types of matter and what is their chemical compositions, and all will be on the basis of that chemical compositions we will be dividing the matters in chemical classifications. Okay, so coming to the physical classifications, physical classification of matter, if you see, then in these classifications matters are classified into three categories. The first one is what? Solid, second is liquid, and third one is gases. So solid, which kind of matter we call it as a solid matter? Those matter which has definite shape and volume, we call it as a solid matter. Like this marker is a solid matter, it has definite shape and definite volume, so it is called as a solid matter. Okay, you got it. Liquid, liquid have definite volume but do not have liquid have definite shape but do not have definite volume. Okay or not? Like liquid, whenever you place in whichever containers, it will take the shape of that containers, and so that's why we can say that it will not have definite volume. Suppose if I have placed it in a cylindrical glass, it will take the shape of a cylinder. If I place it in a conical container, it will take the shape of a conical container. So liquid, we can say that it does not have different shapes and volume as well. Okay, so next, coming to the gases. Gases does not possess definite shape, definite volumes. Okay, so you can see that in our atmosphere also there are so many gases. So we have not seen that oxygen is cubical in shape or hydrogen is cylindrical in shape, right or not? Why? Because they are shapeless and they are volumeless. Okay, they do not have definite shapes and volume. Okay, got it. So this is the basic information. This thing all you have learned in class 9, just revision. So this is the basic informations about physical classification of matter. On the physical basis, we have classified matter into three: solid, liquid, and gases. Solid, they have definite shapes and volume. Liquid does not have definite shapes or volumes. Okay, gases does not have definite shapes and volume. Okay, next, coming to the chemical classification of matter. So chemical classification of matter, mainly chemically we have classified matter into two categories. First is what? Pure substances, and second one is a mixture. So what is a pure substances? Pure substances, basically we are understanding this way. It consists of only one type of particles. Okay, it consists of only one type of or you can say that same type of particles, or you can say in other way, those particles which have same chemical composition, it is consists of those substances which is made up of only one type of particles of same chemical composition. Now, they will be called as what? Pure substances. For example, gold, gold, silver, and NaCl's. All these are what? It has the same, those particles which it is made up of, all those particles has the same chemical compositions. As a result, this one falls under the category of what? Pure substances. Okay, got it? Again, I'm telling you, pure substances are those substances which consist of single type of particles having the same chemical compositions. Okay, same type of single type of particles will be there throughout. Okay, and the compositions, chemical composition of those particles which it is made up of, that one also it will be same. So they will be called as what? Pure substances. Hope you have understood. Moving on to the next, that is mixture. The second type of chemical classification, mixture. So mixture is nothing but it's the combination of two or more substances in any proportions. Okay, there is no fixed proportion that I have to take or 2 glasses of water, 1 glass of milk. It's not like that. Okay, those milkmen and all who are delivering the milk, they does not fix the proportion that I have to add this much only. they goes on adding until unless the quantity which they want, they have got it. Up to that they will be going on adding, okay, until the the whiteness of that milk has changed or lost its whiteness, then till that they will be adding it, okay. So that means what, in mixture we does not have any rules for combining it, okay. How much you want you can add it, okay. That is that part, those substances which we will be getting it by this way of combinations, we call it as what, mixture. For example, water and sugars, okay. But one thing you have to keep it in mind, the components which you are adding, component means like water and sugar, these two are called as component. So the component which you are adding it, they should not lose their identity. That is what the condition is in mixture. But in whatever proportions you are adding, that one does not matter. Only condition is the component should not lose their identity, okay. But composition is not fixed. Whatever, how much you want to add, you can go on adding. Identities of the component should not be lost. So these kind of combinations in any proportions, we call it as what, mixture, okay. So now you can pause the video and take it down, and then after that we will be classifying further pure substances, mixture and all. We are going to classify it further, okay. Take it down. Okay, so we are going to classify now pure substances, okay. So pure substances we can classify it into two. Number one is element, number two is compounds, okay. These things are very basic, but it is very important for you to understand, because you should not get confused with what is element, what is compound and all those things. That's why I thought of making this video, okay. So elements, what is element? It is the simplest form of pure substances, okay. If you want to break it further, you cannot break it further. That is the simplest form, okay. And neither can be decomposed or built. If you want to make these elements, you cannot make it by yourself, okay, under ordinary conditions. Got it or not? So it is the simplest form of a pure substances which can neither be decomposed nor be built up under ordinary conditions, okay or not. So it is the smallest form of a pure substances. We cannot make it further, we cannot reduce it, and neither we can build it by ourselves under ordinary condition. That is pure that is called as a elements, okay. Now elements we have classified into three. Elements are three types. One is metal, another one is non-metal, and then metalloids. So metal, what is metal? Metal generally, it is generally solid. Metals, they are generally present in solid form. They possess the characteristic like hardness, lustriousness, okay, brightness, and they conduct heat and electricity, okay. Most of the metal, generally I'm telling you, most of the metal, they are hard, they are lustrous, okay, means their surface shines, okay, and they conduct heat and electricity. They are allowing the heat to pass through them, they are allowing the current to pass through them. So those are called as what, metals. So example of metal is gold and iron will be the example of metal. The next type of element is what, non-metal. So non-metal, just opposite of metals, okay. Non-metal are generally non-lustrous. The surface of the non-metal do not shine, okay. Got it? They are brittle means easily we can break it, okay. Got it? And they are non-conductor. Like you can say the best example of non-metal is, you can say that wood is also non-metal. Another thing you can say glass is also a non-metal. They easily breaks and we cannot pass current through them, and they do not conduct heat and electricity, okay. So the best example we have given here is carbon and hydrogen. It is the non-metals, okay. Got it? Okay. Metalloids are those substances, okay, few are there, okay, only few metalloids are there, but metalloids are those substances which has little bit characteristic of metal and little bit characteristic of non-metals. They have properties which is common for both metal and non-metal, okay. So they are called as what? Metalloids. And the example for metalloids is silicon, arsenic, bismuth, antimony. All these are what? Metalloids examples, okay. In chapter number 3 or chapter 7, we will be studying in detail about metal, non-metals and metalloids. All those things we will be studying, don't worry. But in your class 9 or 10 also you have studied this, so you can pause the video and you can take down. I have just written in rough, so but you can make it fair so that your clarity will be there afterwards. You don't get confused with element, metal, compounds, all those things, okay. Got it? So this is about the elements. The elements are divided into 3 parts: metal, non-metal and metalloids, okay. Now the second part of pure substances is what? Compounds. So compound and mixture, generally students get confused. Okay, this is compound, this is also made up of 2 or more substances. Mixture is also made up of 2 or more substances. But the difference is what? In mixture, the composition is not fixed. I told you how much you want, you can add it. How much up to which extent you want to add, you can add, provided identity should not be lost. But in compound, it is also a composition of 2 or more substances, pure substances, but here the composition is fixed. Here the proportions, I mean to say, not composition, proportion is fixed. In which proportions you have to add, that is fixed. Like water. In water, H2O, it is always seen that one mass of hydrogens will be 1 and mass of oxygens will be 8. So water always we get in the ratio of what? 1:8, right? By mass. That means mass of oxygen will be 1 and mass of water will be 8. Got it or not? So this is the water is nothing but it's a compound because its composition is fixed, ratio proportions is fixed, 1:8. So we call that as a compound. Carbon dioxide, that is also a compound, okay or not? Why? Because there also composition is fixed, it's not a mixture, okay. Now compounds are again classified into 2, okay, organic compounds and inorganic compounds, okay. Very important, you should know it. Organic compounds are those substances, okay, which we obtain from the remaining of the living beings or the plant, okay. Those substances which we get from the remainings or of the living beings or the plants are called as organic compounds. And all the organic compounds, they have one thing in common. What is that? All the organic compounds, they contain carbon, okay. Very important, you should remember it, okay. So once again I'm telling you, organic compounds are those compounds or the substances which we obtain from the remainings of the living beings or the plants and animals, okay. And all the organic compounds, they have one thing in common. What is that? All of them, they contain carbon, okay. And examples will be what? Oil, fats and etc. So these are all some examples of organic compounds, okay. Okay, next coming to the second type of compound, that is inorganic compound. So inorganic compound, basically it is a substances which is obtained from the non-living substance. It is obtained from the non-living beings, okay. So for example, NaCl, we get it from what? Seawater. So it is not a living, okay. Then another one is marbles, rocks. All these are what? Inorganic compounds, okay. Why? Because they are obtained from the non-living beings and they really contain carbons. Got it or not? So this was the classifications of pure substances. Pure substances are classified into 2: elements, compounds. Elements are classified into 3: metal, non-metal, metalloids. Compounds are classified into 2: organic, inorganic. So we have done the classification of pure substances. Now we will be doing the classification of a mixture. Till then, dear students, pause the video and take down the notes. So now we are going to discuss about mixture. Okay, pure substances we have discussed. Now we are going to discuss about mixture. Mixture is what? Divided into two types: homogeneous mixture and heterogeneous mixture. What is mixture? Already I discussed with you. So homogeneous mixture is what? A mixture is said to be homogeneous when it has uniform composition throughout. Okay, a homogeneous mixture is also called as what? Solutions. Okay, for example, air. So whatever composition of air is here, same composition of air will be there in some other places also. Everywhere the composition of air is same. It contains nitrogen, oxygen, carbon dioxide. All those gases will be there everywhere, right or not? So air, we can call it as what? Homogeneous mixtures, right? Got it? So composition of air, or you can say that the air is an example of what? Homogeneous mixture, because the composition is same everywhere. Got it? Heterogeneous mixture, and it is non-separable. We cannot separate it. Okay, got it? Homogeneous mixtures, we cannot separate it. Heterogeneous mixture, a mixture is said to be heterogeneous mixture when it has non-uniform composition throughout. Matlab composition is different. Okay, everywhere the composition is different, and this it consists of two components. Heterogeneous mixture, it consists of two different components, and those two different components easily we can see, like water and kerosene. If you add, you will see that the water and kerosene, they will separate out with, right? So that is nothing but heterogeneous mixtures. Here the example I have taken is common salt and sulfur. In this, if you mix it, then you will see one layer will be for sulfur and one layer will be for common salt. Got it or not? So this is heterogeneous mixture and this is homogeneous mixture. Got it, dear students? So I hope mixture is clear, pure substances is clear, compounds is clear, elements are clear. Now you don't have a doubt, so you can pause the video and take it down. Then we shall move on to the next topic. Okay, dear students, now we are going to discuss about some 7 basic units. Okay, these 7 basic units you might have come across in physics also, chapter number 1. Got it? So these 7 basic units, but before coming to this 7 basic unit, let us first understand something, some properties of matter and their measurement. See, there are some properties of matters we have discussed, that there are physical properties and chemical properties are there. So what is physical properties of matter and what is chemical properties of matter? In simple language, I will tell you. I have not given this thing on the board. You just try to remember it if you need. And always remember, when you are watching my videos, always sit with a pen and notebook, so that whatever things we are doing it, you note it down, make a notes. Making notes is always important. Okay, so physical quantities and physical properties and chemical properties. So you can say that physical properties are those properties which we can see it outwardly without getting into it, like our voice, our appearance, okay, our looks, our dressing. It can be seen what? Outwardly, which appears outwardly without bringing about any internal change. We can see it. Those things are called as what? Physical properties. Okay, and chemical properties is what? Chemical properties means you have to bring about some changes in the properties of a substances. Okay, those chemical properties, you can say that, are those properties in which chemical changes in a substances takes place. So chemical properties are those properties in which you will see that there will be some change in the inside, that is in the chemical properties of the substances, there will be some change. Those properties we call it as what? Chemical properties. For example, if you want to see the functioning of my liver or kidney or heart, you have to see it inside, right or not? That means those which we need to enter inside and bring about some changes to see, they are called as what? Chemical properties. And outwardly, which we can see without bringing about any changes, we call it as physical properties. Okay, sorry. So physical and chemical properties are clear. Now one thing you see it, one thing, that is what, to we have learned about physical properties, we have learned about physical quantities, chemical quantities, got it or not? To express these quantities we need some unit, right or not? Something we need it. How to express these physical and chemical quantities? We need some units. Okay, so what is this unit? Okay, we will see. Unit is nothing but, we used to say the SI unit of this is this, that is that. We might be learning, we might be writing nowadays, right? But what is this unit? Like unit is nothing but it's a standard, okay, which is set up by some organizations, okay, which take care of all the changes. Okay, so unit is nothing but it's a standard on the basis of which we measure the substances. Okay, or you can say that unit is nothing but a reference point, okay, with the reference of which we measure the physical quantities. Those are called as what? Units. Unit is nothing but a reference point on the basis of which we measure the physical quantities. Okay, got it? And in the France there is an Academy of Science which take care of all these units related things. Okay, in France there is an organization by the name French Academy of Science. They take care of all these units. Okay, so when you go to different countries, the different units is followed. Like here in India we measure the bananas by dozen. Even in India also, if you go to Tamil Nadu or other places, they like we get some things here in kg, there they will measure it in dozen. Okay, so different areas, different places, different units are there, so it will create lots of, like here we measure it in kg, there they measure it in pounds. All those different countries, different measurements are there. Got it or not? So in order to remove all these sorts of confusions and all, there is an unit which is internationally accepted. Okay, which is internationally accepted, and that unit we call it as what? SI unit. That SI unit means International System of Units. Okay, which is internationally accepted worldwide. Okay, fine. So those are called as those unit which is internationally accepted, we call it as SI units. So basically, first of all we are going to see 7 basic units. Okay, basic unit means fundamental units. These are the these are the, you can say, mother of all the units. All the units has been derived from this unit. So these units are called as what? Basic unit, or we call it as fundamental units. Okay, of 7 physical quantities. Got it? Rest of the units are all derived from this. Okay, so they are called as what? 7 fundamental units or 7 basic units. So what are those physical quantities? 7 fundamental physical quantities are what? Length, mass, time, temperature, electric current, luminous intensity, and amount of substances. So what will be the symbol of length? The symbol of length is L. What is the symbol of mass? M. Time, small t. Thermodynamics, temperature, T. That is in simple way you understand temperature, T. Electric current, I. Luminous intensity, IV. Amount of substances, N. Small n. Okay, so these are the 7 fundamental physical quantities. These are their symbols and the name of the units. What will be their units? That is reference points. So length basically we measure in meter, so the unit is meter. Mass we measure it in kilogram, so it is written here kilogram. Okay, time basically we measure it in second, so it is written here second. The unit of time is second. Temperature ka unit is what? Kelvin. Okay, name of the unit. Electric current ka unit name is what? Ampere. And luminous intensity unit name is what? Candela. 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 Amount of substances unit is what? Moles. So when you write the symbol of these units, the meter symbol is M, kilogram symbol is kg, second symbol is small s, Kelvin symbol is capital K, ampere symbol is capital A, candela symbol is CD, and mole symbol is mol, MOL. Okay. So these are the 7 fundamental physical quantities with the reference to which we derive the other quantities. Got it? So other quantities other than these 7, they are all called as derived quantities. Got it, dear students? So this is very, very important both for physics and chemistry as well as for your future. So learn it properly. This one very, very important it is. Okay. Okay, so take down the notes. Okay, dear students, now we are going to discuss on very important things. Most of us, we are having a problem. We don't learn this, and simply we think that this is just we know everything. So like this, you will not do this here. That's why I have spent the time for this portion also. Okay. So prefix used before the name of basic units. Okay, basic units, in some questions you will see this prefix will be used, okay, before the name of a basic units. Okay, like meter is there, so sometimes you will see they will be using this one, this symbol meter, no? So for example, let's say they will be using micrometer. Okay, these are very, very small one. Okay, sometimes you will see mm, that is called millimeter. Okay, sometimes you will see cm, centimeter. Sometimes you will see pm, picometer. Okay, so these are the names, these are the symbols which we see before the name of a basic unit. Basic unit is what? Meter or not? So before this name you will be seeing this symbol. So if this symbol is there, then what we should multiply with, I will tell you, and then I will show you some examples also. Okay, so multiple, how much we should multiply, name of the prefix, and this is symbol. If it is written there, symbol is C, then we'll write centi. The C means what? Centi. And what will be the multiple? 10 to the power minus 2. For example, I will tell you, it is given 1 meter. Okay, or if it is given like this, 1 centimeter. Now if I want to convert this 1 centimeter into meter, what I have to do? 1 into 10 to the power, centimeter, how much? Minus 2 or not? So minus 2. Okay, 1 into 10 to the power, suppose this is given meter, so I want to convert in centimeters. It will be what? 1 into 10 to the power minus 2 centimeter. Understood there, students? Okay, next, 10 to the power minus 3 millimeter. Okay, so it is, if it is given like this, 5 mm. So what we have to do? How we will be writing 5 mm? We will be writing 5 into 10 to the power minus 3 meter. Got it? If you want to convert into meter, so it will be multiplied by how much? 10 to the power minus 3 meter. If m is there. Okay. Next, 10 to the power minus 6, it is called, name of the prefix will be what? Micro. And if it is like this, okay, if it is given suppose 5 microfarad, this is called 5 microfarad. So farad it is called as. Okay, we will study in physics, electricity. 5 microfarad, if it is given like this, and if you are asked to convert into farad, then what we will be doing? How we will be doing this? Micro represents what? We know the symbol micro. It is how much? 10 to the power minus 6. So write 5 into 10 to the power minus 6 farad. Okay, dear students, I hope you are understanding it. Okay, next is what? 10 to the power minus 9. So 10 to the power 9 means nano, and symbol will be n. So suppose wavelength is given 520 nanometer, like this. Wavelength, it is very small, so we measure it in nano. So it is given 512, or just assume that 12 nanometer. So 12 nanometer, if you want to convert in meter, nanometer means how much it is? 10 to the power 9, right? So right here 12 into 10 to the power minus 9 meter. Are you getting my point, dear students? This is the basic unit. and prefix of basic unit is n. So for n symbol it is nano, and how much is the multiple? 10 to the power minus 9. Next is what? Pico. So for pico symbol is P. Suppose bond length, basically we have discussed in chapter 3, 4. Bond length, it is measured in 156 picometer, right? It is given like this. So before meter, pico is there. So how will convert into meter? Picometer is equals to how much? 10 to the power minus 12. So like 156 into 10 to the power minus 12 meter. Understood, dear students? I hope you are getting it, how to use this. Next is femto. So F, and how much it is? 10 to the power minus 15. So suppose if it is given Fm like this. So what does it mean? Femto. Femto means 10 to the power minus 15 meter. Like this it will be coming. Okay. Then next is Japto. So symbol is Z. So how much you will multiply by? 10 to the power minus 21. 10 to the power minus 24. Yapto, and symbol is Y. Sometimes once it was asked in the competitive exam also. Okay. What is the multiple of Yapto? Or 10 to the power minus 12 is called as what? Yapto. Got it? So that's why sometimes these basic things also is to come in the examination. So that's why, dear students, it's important. Take it down and try to learn it. It will help in not only in physics but also in chemistry, in bio as well. Okay. So this is negative one. Now we'll take down the positive one, positive prefix. Okay. Got it? So pause the video and take down. So now we are back with the positive multiples. Previously we have discussed about negative multiples. Now we are going to discuss about 10 to the power positive multiples. Okay. So if 10 to the power 2 is there, the name of the prefix we will be using is what? Hecto. What is the symbol of this? H. Okay. Got it? So suppose if it is given 1 hecto. So 1 hecto equals to how much? It will be equals to 10 to the power minus 2. Okay, got it? So 1 hecto is equals to 10 to the power minus 1 hectometer is there. Suppose it is 1 hectometer. So it will be equals to 10 to the power 2 meter. Got it or not? So like this we will be using it. Suppose it is given here 1 kilonewton. Okay. 1 kilonewton, that is how we will be writing it. 1 kilonewton, we will be writing 10 to the power kilo, and what is the multiple? 10 to the power 3. So we'll write 10 to the power 3 newtons. Got it, dear students? How to use it? If it is given kn, that means kilonewtons. So kilonewton, how to convert in newton? 10 to the power 3. Kilo means 10 to the power 3. You have to multiply it. Okay, whatever number will be given. If it is given here mega m, okay, m byte, okay, we used to write na, got it? MB, got it or not? We used to write it MB. So that is nothing but megabyte. Megabyte is equal to our 10 to the power 6 bytes. Okay, bytes. Got it? In computer, these are very huge quantity, so we basically use this in computers and all. So gigabyte, so GB, we used to say GB. So GB, so GB means how much byte it will be. Gigabyte means GB means how much byte it will be. It will be equals to 10 to the power 9 bytes. Okay, got it? Understood? So terabyte, so symbol will be what? T. And what is the prefix we are using? We are using 10 to the power 12, and giga 10 to the power minus 10 to the power 9. And peta, capital T, we are okay, we are using here how much? The symbol is how much? P. What is the symbol? P, and name is what? Peta. 10 to the power 21 zeta, symbol is Z, and 10 to the power 24 iota, and the symbol is Y. So these things may sound very silly to you, dear students. Some of you might be thinking, sir, what you are teaching, these things so we already know. If you know, well and good. but I am sure most of you might have neglected all these things. And if suppose in case questions come from these portions in your competitive exam, in your board exam, that time you will regret why I didn't study. For that only I have given these things. And when conversion comes in the numericals, convert meter into kilometer, convert kilometer into meter, all those things comes, means you are getting stuck. Those things will be solved with this, since it is what some basic concepts of chemistry, so basic you should learn it properly. Okay, dear students, so you can pause the video and you can take it down. And till now, if you have not subscribed my channel, okay, density classes, please don't forget to subscribe my channels. Okay, and some videos are also there in my another channel, that is Academy Master. If you want to watch that chapter 12 videos, the earlier channels, there also it is there. So don't forget to subscribe the channel Density Classes. And the second part of this chapters, we will be doing it in the next video. Okay, got it? So thank you so much, and please watch the video properly and share with your friends. Thank you.